Well, hello everyone. Thank you for joining us today at Snyk Live, our first episode, our first broadcast going live here today. So what we have in plan for you today is Benji Kalman, Director of R&D, joining us for Security RnD at Snyk, and Sam Hepburn. I'm going to add them in right now. They can say hello and chat with us today about security and other topics. Hey.
Hello. Thanks for having us, Ran.
Of course.
Very excited to be here.
It's a pleasure. So we're going to say a little bit about, what is Snyk Live, what we're doing with these episodes. And basically for us, this is having fun, having a bit of, casual discussions and demos and live streams and all of those things live with you. So we are really looking forward for all the comments in the chat on YouTube or Twitch. If you're joining us on any of those channels, please engage. We're here for that. And, this is a bit of a less formality, so, feel free to sidetrack or joke around if you wish, Sam and Benji.
Jokes, we don't do jokes. We're very serious, yeah.
All right, cool. So let's kick us off with some intros. So, Sam, why don't you go first?
Cool. Hi, everyone. I'm Sam. So I have the unfortunate day job of working with these two humans. And when I'm doing that, I look after our vendor-neutral community called DevSecCon. Now, I think Benji and Laran, you're both members of our community, aren't you?
Of course.
What is this DevSecCon? Can you tell me a little bit about it?
Yeah, so DevSecCon, for those of you who haven't heard of it, which I'm sure is none of you, because I'm sure the whole community knows who we are, but we're a vendor-neutral global community, and our aim is to educate and enable people in DevSecOps. So we talk about everything from what Laran and Benji are going to talk about today, across to security adoption, security champions programs, and a whole bunch of other things to hopefully help you to enable security into your software development lifecycle. And we have a cool event coming up. So why I want to gate crash this party is I wanted to tell you all about an event we've got coming up in June called DevSecCon 24. So it's our global round-the-clock live stream conference. We have some great sessions to be announced this week. For those of you in different regions of the world, don't worry. We have agendas covering APJ, EMEA, North America. So wherever you are, there's a session for you. So you can check that out on the web address below. If you have any children or anything like that at home and you're wondering, you know what, Sam, I'd love to come, but I've got to look after the little ones and they're running riot. Don't worry, we are going to give you childcare.
Nice.
What does childcare look like virtually? No, we're not going to watch a 1-year-old through the screen. But we've got a whole kids track available that's going to have cool interactive sessions, science shows, different things, so you can plug them into that and watch DevSecCon with us. Laran, I'm sure you'd like to do that with your little one.
Of course. But also, what about dogs? I was thinking, what were you doing? Is there like a dog here? Is there a dog nanny?
Oh, I wish there was a dog nanny. I'd give my puppy to it. But unfortunately, dogs just don't. They seem to chew the laptop and not really watch anything from the laptop.
That's true. That's true.
I've managed to get something in my eye. Excuse me. The other thing I just want to mention before I stop gate crashing is that all the proceeds from DevSecCon 24 will actually be going to charity this year. And the charity that we select is actually up to our attendees. So when you register to get a ticket, you can nominate a charity. The only requirement we have is charities looking at tech inclusivity. And during the event, you can then vote on those charities and we'll be donating the money across all 3 regions. So really have your say. This conference is for everyone, and we hope you come along.
Well, that's pretty cool. I'm excited for it. What are the dates again? Can you remind all of us? DevSecCon 24?
DevSecCon 24 is the 23rd and 24th of June, kicking off at 3 p.m. UK time, which I think is 10 a.m. in the States, and I have no idea what it is.
10 a.m. somewhere.
Everywhere else in the world.
Cool. Well, thank you, Sam. And are you going to stay a little bit with us here for this? Yeah.
I'll hear what Benji has to say, and then I'll slip backstage to watch the show unfold.
Cool. Sounds good. So we are here with you, Benji. Why don't you, who are you? What are you doing at Snyk, actually? I have no idea.
That's a really great question, Vera, and I don't really know either. But so long as our bosses don't find out, I think we're okay there.
Okay. Good this isn't a live stream.
Yeah, it's okay. They're not watching. I think in general, what we do in the security research group over in Snyk is we basically help power all of the various products that Snyk creates from a security perspective. So we're in charge of everything that has to do with gathering the data and the security knowledge, which powers all of the various products. So whether this is from like Snyk's SCA offering, where we're looking at all of the vulnerabilities in open source software, or the container offering where we're doing something similar for container vulnerabilities, or more stuff such as SAST or IAC, where we're looking at the various rules that we need to be able to put in order to look at security, in order to be able to look at security knowledge and information. This is the kind of stuff that we're trying to do and help out as much as possible. So we got a dedicated team of analysts, researchers, engineers, data scientists, all of who are bringing the skills together in order to create like the best possible offering for all our users and for the community writ large, really. So yeah, that's kind of what I do.
That's a lot. That's a lot. And Francesco on the stream has already mentioned you're his new idol. I don't know why, but
I got very flustered. I I think you saw when that popped up, but that's fine. You must be used to it by now, Liran. But like, I don't know. It's very difficult.
I'm not even getting those level of comments. This is all you, Benji.
Truthfully, I understand.
Cool. So I was thinking we could like open up with a short icebreaker for what would happen here. So how did you get into security? What was your journey? And you could roll with it as old or as recent as you would want to.
Yeah. So I actually got into security mainly around my military service, where there was a kind of a thing that I was sort of pushed into. I didn't really think about doing it myself, but the powers that be decided that I was slightly more intelligent than I looked, and I should go and join and do something a little bit in the intelligence there, and began really looking and digging into this whole security space at the time. So I spent around 5 years really digging into that and getting to know a lot of different places where security and cybersecurity was really, really relevant. And it was a really, really interesting thing to sort of get into. And then I left and went to university and immediately decided to not do anything like that at all and to go and study philosophy instead. So I spent 3 years studying doing a PPE, which is philosophy, political science, and economics. But at the end of the degree, I found out that I had to still pay bills, unfortunately. So I ended up going to decide to continue this career, like a very interesting career of security, and in various different companies, and began working both as a security researcher, as an analyst in a few different companies, and eventually found my way to Snyk, where alongside the rest of the company, been able to grow into the current role that I'm in now, and just learn more and more each and every day, which is amazing.
It is. And look at that journey, philosophy. That doesn't pay the bill, you're saying.
No, it doesn't. The very first company I interviewed for, they looked at my degree and they were like, well, I mean, you've studied philosophy. So how do we know that you really care deeply enough about this role as a security analyst that we should hire you? And I looked at them and I said, listen, you're right. My first choice is definitely philosophy, but you can't be a philosopher anymore. So you can rest assured that this is my second choice, but will never ever leave you to become a philosopher. And I've kept that my word.
Philosopher, I guess.
Yeah.
All right, cool. Love that. Kind of reminds a lot of people probably the journeys that they hear going into security for folks in Israel. So love that we've got you here with us at Snyk. What is a recent project that you worked on and you want to share? This could be anything. Did you organize your CD-ROM collection at home recently or something? Use the COVID downtime to do this, alphabetically sorting something?
I mean, it's such an embarrassing question to ask somebody in a COVID year. It really, really is. I'd like to pretend that I've done something. Can we pretend that I should be doing something now that we're able to go out of our homes a bit?
Yes,
I think basically, like everybody else, I've invested heavily into like my spice collection for cooking and also for cocktails. And I think probably I've gotten pretty good at that, and I think so has everyone else. But those are the only big projects that I've had the opportunity to dig into outside of work.
Is this a side hobby, like cooking for you, Benji?
I mean, I think for most of us, because like we need to eat food. But I started getting very good at it before COVID because my wife was studying for her postgraduate degrees, and it was pretty intense. So we started cooking more and more, and we started doing more and more gourmet meals. And then it kind of bled right into COVID. So we just like went OTT. So yeah, I highly recommend it. Next time we're on the show, we can do a cooking show. I hear it get most views anyway, and we could like really do something here, man.
I love that. I love that. I'm gonna take you on this. So be ready with your spices and everything you need there.
Yeah, no props.
Okay, is this gonna be your prediction for 2021 as well? Doing mastering cooking?
My prediction for 2021, I think people are going to get a lot more tanned in 2021 than they were in 2020. That's my prediction.
Okay, especially if you are going to visit Israel in August, right?
Yeah, let's hope. Let's see the situation.
All right, cool. So I thank you for this intro. I'll to get us all back into why are we here, right? So thank you all for joining. And this is a talk about harnessing security expertise to power SAST and code security. So as we are gonna dive right into it, and I appreciate Benji's own kind of like intro and background into kind of this topic. And Benji, do you want to tell us maybe kind of like working in the security research field, for several years here, how a vulnerability is born? Like what happens? How does the things work?
Sure. I think a vulnerability being born, it's a very poetic way of looking at it, for sure. The question really comes down to like, what is a vulnerability? A vulnerability is a bug which is useful for someone, right? So like, how do bugs happen in code? There are many, many reasons for it, but a lot of the time because code is pretty complicated and it's difficult to understand all of the different outputs of the way that it works. It's certainly very difficult to understand all of the different outputs and things that it will work when it interacts with all of the other complicated bits of code that it's working with. And sometimes it happens because people make mistakes. Because we've all had a day when we've committed a little bit of code but without looking at it that one extra time, or that PR which came very late in the day, Friday probably, and we merged it in, and we introduced a little bit of a problem into the situation. So some of it is human fallacy, and some of it is like just machine complication, which kind of happens, and it's a natural part of programming. Like vulnerabilities, sometimes I think we see in interactions with various people, like people are upset when there's a vulnerability found in their code, or people could even be offended that there's a vulnerability found in their code. They think that somehow it's like a badge of dishonor or anything like that. But really, it's just about coding introduces at a certain point in time vulnerabilities, always will, and always has been. And it's just about how we deal with this in the simplest way possible and the best way possible, and move on. It's just a natural part of coding, really.
Got it. It's basically a security bug, right? Like if you'd open a bug from my repository, from my project, I'd probably maybe be offended in a way, look at it as kind of like maybe I did a mistake there. And this is kind of the same thing, but it's security related.
Yeah, I think there's like an extra, like it really is just a bug which happens to have a specific implementation that could be security related. But I think there might be extra tension involved when it comes to security. And I think part of that is really on security researchers and analysts' fault for over time by making this into like a big hoo-ha around this and everything else. But it's like something that it's much better to just talk about as this is a natural part of the ecosystem. We have bugs in our code. We can have fixes. One of the great things about open source is that you have a million different eyes on this, which can help you find the bugs, which again, as all humans, we're a little bit like, open to fallacies. It's helpful to have a friend help us out.
Great. Okay, we'll talk about maybe bug bounties in a sec, but I like that you've mentioned kind of like security analysts and research, and it's really kind of like weaves into kind of like my next question here, which is what do they do? So what do security analysts or researchers, which is maybe kind of like maybe the two sides of the table or something? I don't know. What do they do? What's the activity like day to day? What do you do at Snyk?
So, I mean, I think it was really security analyst, security researcher are probably the two most overused and overabused terms in the business today.
The size of the work that they do.
Yeah, just the size, the different types of work that they do, and certainly from company to company. But even inside, I would say, inside the group, we have a lot of different people with a similar title doing very different kind of work, because there's just a lot of different things here, and I don't think we've quite build out the lexicon of different languages that we need to describe all the things. I ended up writing like about 2,000 words a blog trying to explain what it is that analysts did, and within a month it was irrelevant because there were already about 1,000 other things that people were doing as well. But to answer your question and not like just give you a non-answer, I think a lot of what happens here is the analysts and up to the researchers to a great degree, what we're doing is we're looking at a lot of input that's coming in from various security places. Some of these are like databases of vulnerabilities, and what we're doing there is trying to like verify that these vulnerabilities really are vulnerabilities themselves. We're trying to make sure that we're trying to give better descriptions and analysis on these vulnerabilities to help people understand them, be able to triage them better. And we're trying to add additional metadata to them, which will make sure that they're actually accurate. So like that we're actually marking the correct packages and the correct versions. We're finding the actual vulnerable code that's relevant to this, and also applying the right severity here as well, i.e. how really damaging is this vulnerability to us? We use something called the CVSS v3 vector, which has a lot of different components to it, which kind of help us determine how vulnerable something is. And this is everything from like how likely this vulnerability is to be affected. So like what are the things that you need to do in order to use this vulnerability, to how severe could the impacts be as well. And that helps. All of this kind of stuff goes in to help us analyze all of the different vulnerabilities that are coming in. There's another layer that we also add on this, is which more researchers come into as well, which is looking at additional vulnerabilities and researching new vulnerabilities well in the ecosystem, or also just picking up on all kinds of different leads and chatter about things which might be vulnerabilities, and understanding, is this code actually vulnerable, writing POCs, discussing with maintainers vulnerabilities that have been disclosed, and helping them also try and get fixes to them and get them after that disclosed to the community at large. And of course, there's a whole lot of work that we do inside the kind of SaaS product as well, where we're really looking at wider vulnerability trends and the way that code is written in order to introduce vulnerabilities to it to begin with. And we're doing a lot of research there into the way that code works and frameworks work in order to understand how vulnerabilities can be identified and also fixed from people.
Got it. So this is kind of looking at the whole trend, is like maybe a family of vulnerability types, and seeing if there are repeated patterns and cross projects. And cool. Yeah, for everything you said, which I realize also for you, if you had more time, you'd probably dive even more into it. But it sounds like this is a lot to do. You mentioned a couple of kind of terminologies. So you mentioned CVSS. That's the Common Vulnerability Scoring System. So what is that used for? Just for people on the call or developers not really related, knowing the terms?
Sure. So a CVSS is a vector which has a bunch of different components to it, which allows us, i.e. people triaging vulnerabilities, to assign a specific severity to tell people looking at this vulnerability, i.e. developers or other security-oriented folks looking at this, how problematic this vulnerability is, and also how can this vulnerability be used against us. So there's bits in there in that vector which have to do around what is the type of vulnerability, i.e. can this be achieved via a network, or does this have to be a localized instance? And there's also stuff in there around what privileges are required, like do you need to be an admin to do this? And obviously, if you need to be an admin to implement the vulnerability, then the risk there is significantly less if you don't need any kind of privileges at all. And finally, there's also bits there around what kind of impacts there are of this vulnerability. So does this, in fact, the availability, kind of like denial of service? Is this something which has to do with confidentiality, i.e. is this leaking sensitive information? Or is this what we call integrity, which is really, it's remote code execution, i.e. can I actually run stuff on the server to get things or do things or make it behave kind of funny in a way that I otherwise would not want it to? So that's what a CVSS vector is, and that's how it helps us kind of determine these vulnerabilities. The other thing that we do there is also we add stuff around exploits. And the same way there, like if there's an actual exploit published for a vulnerability, then there's also a bit of the CVSS vector that we can use to identify that and explain how mature that exploit is, whether it's like a simple POC or you got like a Metasploit plug and play that any kid can sort of run.
Right. That is important because if there's an exploit for that, I guess someone could weaponize it, and it's then easy to automate all of those kind of like low-hanging fruits of known vulnerabilities in code, right? That's kind of like why you want to promote the urgency to fix these kind of things.
Yeah. The research that we've done, and this isn't going to surprise anybody, right? But that a vulnerability with an exploit is far more likely to be used inside a breach. I think it's like 5 or 6 times more likely to be used inside a breach than any kind of vulnerability which doesn't have an exploit. I mean, it's just a case of everybody's doing path of least resistance. So if you can do, as you say, like plug and play and just run a whole bunch of vulnerabilities against somebody, you're going to go for the people who have the leaky door open. And those are the people who are going to get attacked first. So it's always about your security posture and making sure that you're getting rid of those low-hanging fruit and you're as secure as possible.
Got it. Yep. So maybe from that, let's talk about responsible security disclosures, which your team handles. Right. Maybe what is it in short? And I'm happy to hear, if I won't get you into trouble, maybe some war stories, some fun stories, whatever you want to, if you could share on some of this. I'm not going to hold you up to it because I know this could be some stuff private. So feel free to kind of like navigate this as you wish.
Sure. So, I mean, maybe I'll just start by explaining what it is that we're talking about when we say vulnerability disclosure, or also known sometimes the responsible disclosure or an organized disclosure. So basically, this stems from a very first thing, which is if you find a vulnerability in somebody else's code, you shouldn't go and shout about it. And the reason is that if you do so, then other people who are less nice than you might use it against that person or the people using that code as well. So what kind of exists is a system of responsible security disclosure, which is a way to let the people know whose code it is that is vulnerable, that their code is vulnerable, and give them a window in order to fix that vulnerability. Yep. And during that time, this information is embargoed, i.e. you're not going to tell anybody else or put it else out there. And the idea here is to find the balance between letting the world at large know that there's a vulnerability so they can be safe, while also not being irresponsible and giving this information too quickly to people without a fix kind of being able to allow. So normally what happens is you're given a set window. This ranges from like 60 to 90 days, or generally like the community's averages, to allow people to fix this vulnerability and publish a new version with this fix or a patch with this fix before you kind of make this any more public, at which point you publicize this to, again, let people be as safe as possible. So that's the idea behind this. One of the things that Snyk does is that we step into the breach here of responsible security disclosures inside the open source ecosystems that we support. So for all of the various open source ecosystems we support, this is npm and Python and Golang and all of these various languages. We also run a responsible security disclosure program where we let researchers come to us and let us know that they found a vulnerability inside an open source package. We have a look at it. We verify that this is in fact a vulnerability and like ascertain that we think that this is worth going and speaking to the maintainer, wasting their time with it. We then reach out to the maintainers to let them know and basically begin this responsible disclosure process with them. During this interaction with the maintainers, what we'll often do is we'll come and we'll say, look, we found something, or somebody has found something and told to us that to us looks like a vulnerability. Can you please explain to us your opinion on this? Because at the end of the day, the maintainers have much, much better understanding of their code base, how it works, how it's supposed to work, all of that kind of context. So we can come with a security context and say this is likely to be a vulnerability, but a maintainer might be able to say, no, this isn't, because this program is never ever supposed to be used in any kind of user-facing instance. Therefore, it's entirely in the back end, so it doesn't matter that the input isn't sanitized, for instance. That's the kind of input which the maintainer is more likely to be able to know and tell us. That's a simple example of that. But there's a lot of other stuff as well. So it's really important when having these interactions with maintainers to maintain that kind of like open approach to how it is that we kind of do this. And we work with them afterwards to ascertain that they also think it's a vulnerability, and then to help potentially fix this vulnerability with them if they need that help. Often they're able to just simply do that themselves, as you well know, and then get this basically to the point where we can disclose this to the public at large. And that's how like the responsibility disclosure program kind of works on our side. Now, there's always a little bit of controversy around disclosures and vulnerabilities as a whole, as I think you were alluding to. And I think we spent about 2.5 years getting a bit better at understanding how this responsible disclosure program works and what is the best way to kind of work with here. And I think a lot of the lessons that we learned here around how best to approach maintainers and how to talk to them in the context that they have are things that we learned after we made some mistakes here and there. So like we went and we thought that something was definitely a vulnerability. And so when we approached the maintainer, we said, we found a vulnerability in your code. And they, got really alarmed at us and were very, very upset because in the end, it really wasn't a vulnerability. But we felt we were just starting a conversation. But they felt very threatened by the fact that a security company was coming to them and telling them they found a vulnerability and what's going to happen next. And that was a lesson for us to learn of like where our own power was and how we could be perceived. Because, we were a couple of people messing around in a WeWork. We didn't understand kind of what the perception of Snyk might look like, even 2 years ago, of what that might look like in the community at large. So that was a really good lesson for us. And I mean, once you've been shouted out on Twitter for disclosing a vulnerability which someone didn't agree with, and you've had a lot of flame thrown at you, I think you learn more and more how it is that you can best approach this and really get to the best compromises in terms of keeping people safe, while obviously respecting maintainers, their code base and the huge amount of efforts that they put into this.
It's a nice story, yeah. And Benji, you're not enough on Twitter to actually get that hit. So,
well, this is why I'm not on Twitter, Leon.
Yeah, this is the mistake I'm doing, right?
Yeah, but you get that hate, and then you come to me. But yes,
yeah, it's a tough line to kind of like navigate around, just because, as you said, like there's the notion of helping maintainers. Maybe we found something that's a legitimate security concern and we want to bring it up, but also there's the other part here, which is with open source, that's maintainers. And most of the time, right, this is people having life and work, and like they're trying a project voluntarily, doing that side project, weekends, nights, something. And we're kind of like looking, at them to kind of like, give us some kind of context, because if not, the disclosure, might need to go publish. And I've definitely had my share of kind of these experiences, so I can totally relate. And I'm happy we're doing better at that. So I think the ecosystem in general is understanding, kind of like where this goes and kind of what's the I'd say the motivation around fixing security issues as well and attending to them. But you, as you said, like you're a major of philosophy, and there's like an entire philosophical debate that's going on with people on the Node ecosystem, like Matteo and others, discussing about maybe we should also kind of like reward maintainers for fixing something and kind of like help the ecosystem and so on. So I won't go into that, but I'm definitely echoing all of that, and love to hear that story as well. So before we kind of dive into the whole SAST and security expertise and your finding of vulnerability in a project, that's a really cool one. We're going to do a live hacking in a sec here. There's a question from Francesco that I do want to kind of show up. It's not entirely related to this topic, but I'm happy to take that one as well. So Francesco said, I have 3 questions, which is kind of like talking about the relationship between Docker and Snyk. What images do we support? And how does Docker scan related to Snyk? Okay, cool. So basically, this is an official partnership between Snyk and Docker, which the Snyk database and all the Snyk kind of like vulnerability database and the information that basically what Benji's team's kind of like working on and what we've been sharing here. This is what powers all the insights that you get when you find security issues in your Docker containers through Docker. So this is whether you installed the Docker desktop, or you're in the Docker Docker Hub UI, or maybe you ran a Docker scan, which is the CLI command. This is all kind of like powered and pulled by the Snyk behind the scenes. This is kind of like the integration that has been happening to basically allow developers, right, and DevOps and whoever works with Docker containers, which is probably today like everyone, to allow them to basically find information about vulnerabilities that exist in their images and the way that they've built them. And we've actually written quite a few, step-by-step and blog posts around this, which I'll kind of like leave in the show notes after the show is over, in the links. Benji, is there anything you wanted to add on that one?
No, I think you got it. I think the project is like, and the partnership has been really, really, really great, both for Docker and for Snyk and for like everyone using Docker. And we're happy to keep on helping out the community in any way we can.
Yep. So with that, let's just dive in a bit. So the point here is we were thinking, Benji, you and I, that we were gonna maybe talk about a vulnerability that we found and actually show like what exactly is going on there. What is this, deep security expertise that kind of like needed to understand maybe how vulnerabilities, like we said, like come to life, like how a vulnerability gets, is born. And so, maybe kind of like to lead to that, like what are some common security issues that you've seen as being active as a security researcher as well, that developers kind of like tend to repeat? What are the the stuff that you usually found, and or usually maybe obvious issues and not false positives?
So yeah, I mean, not to generalize too much, but I think one of the things that we do, and I think I talked about this a little bit at the top, is we look at trends of kind of vulnerabilities that are repeated time and time again. And we do this both to discover new vulnerabilities ourselves in order to be able to do this, but also to be able to write like rules, for instance, for SAST in order to look at this. So a classic and great example of this is kind of what happened in the prototype pollution in the Node ecosystem. And this was probably this probably hit the height a couple of years ago, but we're still finding more and more vulnerabilities there. But I mean, you had a vulnerability type, which was there was a very common usage, in this case, which was a legitimate usage, in this case, merge. So it was very common to want to say that you would want to take all the properties from one object and move them over to another object inside the inside the ecosystem. That was like a good use of code that would make sense to kind of like to have this happen. And you also had there was a need inside the ecosystem to do a certain function. So it was very, very common. And that's where you get like commonality. So that's where you get a lot of the same code, similar code written time and time again, doing the same type of thing. In this case, it was taking various objects and doing what we call a recursive merge. So merging an object so that merging an object recursively. So this kind of thing is where you would then, so then there's another thing which kind of happens here, which is there's also like a little quirk of the language. In this place, it's kind of the magic properties of the objects. So this is the kind of thing which means that like there are objects inside Node which have certain magic properties, proto properties, which are essentially properties of object itself in Node, i.e. not a singular object, but like object itself, which is something which we kind of which is something which makes a lot of sense for the language to kind of have. But together, these two things happen to lead to a security vulnerability, which meant that you could, by using a deep merge function or a recursive merge function, you could essentially poison the actual prototypes and the actual magic properties of the Node object, not just the Node object that you were looking at, but of all of the objects then inside the environment that you were working in. So, for instance, you could suddenly, if one of these magic properties, for instance, of the object told it that it was an integer, you could suddenly tell it was a string. And then, for instance, well, a lot of things don't work if they're supposed to be, if they're integers and they're suddenly strings. So that's a very easy way to like DOS an entire system. There are like more sensitive things that you could do there as well, even getting up to like remote code execution in some cases. But it was this kind of thing, which is you have very, very common usage and a core part of the ecosystem which is attached to it. You're likely to find lots and lots of similarities in the kind of vulnerabilities that you're going to find, because you're likely to find people wanting to do the same thing over and over again. So when we kind of looked into this, we were able to find like loads of prototype pollution vulnerabilities inside the ecosystem. And we spent a lot of time, like about a year and a half ago, finding and disclosing them and like helping to fix them inside the community, like community at large. And there's a few other examples of this as well, but I think this is kind of like a good example to show what it is when you get a common vulnerability type and how you're able to identify and help out there.
Got it. This is mostly about prototype pollution, but we are today going to look at something else, right?
Yeah. So we're looking at the type of vulnerability we're going to look about now is also a pretty common vulnerability type. It's called Path Traversal. And again, here, like there's a kind of a similar thing which you would sort of do. So Path Traversal is a vulnerability type, which basically means it allows users to traverse into parts of the file path which they really shouldn't have access to. So for instance, if you wanted to let somebody access, say, all of the documents inside a certain folder, it allows them to traverse up the file path, say to like your root folder, in which place you might have sensitive information such as passwords, which you really didn't want every single user to be able to look at and gain access to. So, and the flaw here again is there's a very common usage to want to allow people to access files from a file system, but not necessarily have the right sanitization or right checks in place to kind of to stop people traversing up that. So it's again this common usage of a need to access files. And the simple fact is that like the natural ability to traverse files in most languages allows you to move up the file chain pretty much unstopped. You need to put some kind of limits in there or some kind of gating in there to stop this.
Got it. Okay, so let's look at some stuff here. So this is the Path Traversal report for the project that we are going to talk about, right?
Yeah, so I think this is a vulnerability in browserless Chrome, which is a package that we identified a vulnerability, and we did this about, I think this is 9 months ago now, was when we maybe first sort of found it, when we first sort of found this. And I think, and we disclosed this back in October. And the way that we found this is that we were actually doing our research into Snyk Code when we were adding the rules to JavaScript for Snyk Code. We looked and we were building a rule for Path Traversal. And part of the way that we check to see if our rules are actually accurate is we go and we test them out on real world projects. Some people kind of do this in like all kind of benchmarking, like things like OWASP 10 and stuff like that. It leads to very inaccurate results at the end of the day because they don't really represent what the real world looks like. So what we try and do is, because we also have a large database of vulnerabilities that already exist in real projects and real code that's been written, we like to test this out against known vulnerabilities that we know of and other packages as well. So when we were doing this, we identified this vulnerability in really quite a popular, this is actually really quite a popular project, mostly in Docker for browserless Chrome. And it had this Path Traversal vulnerability, which we were able to sort of disclose.
Right. So, I mean, I'll get into Snyk Code in a second if no one had heard of that before, but it's pretty interesting that what we found is basically, this is the project, right? It has a website, there's like e-commerce, there's a company around it or something. So like this is a project that, while is built on open source, is an actual live thing. So that's going to be an interesting thing to see how it works. And browserless Chrome here is kind of this idea of like automating. So if anyone is like new to this and what this actually is, it's the idea of like automating the browser to do specific actions, usually used for like end-to-end testing and things like that. But you could do different stuff like taking screenshots of websites and PDFing them and, doing whatever you want on them and so, things like that. So let me go back into, I just want to kind of like give everyone a little bit more information here. So what are we seeing in this Path Traversal report that's, by the way, on the Snyk database, right? I've got that open here. So this is the Snyk database. If you were to visit this website, you'll find different ecosystems where Benji's team and the whole security research team, the security team at large at Snyk kind of works on anything from Linux, so the whole Docker containers kind of like kind of rolled, and up to language ecosystems like NPM and others. I always find it a little bit like fascinating / funny to like browse, every few weeks here on NPM, see what's new. I love all of the all of the finding with basically asterisk, which means kind of like no fix, so no upgradable versions, which is something that we need to be aware of, right? When we work with open source and dependencies and things like that. But I'm sidetracking here. I'll go back into the Path Traversal because we were chatting about a few things here at Benji, right? We said CVSS, which is this. So if developers haven't seen that before, this is basically the severity of the vulnerability, right?
Yeah. Yeah, and you can see here the kind of components that I was talking about and the way that it works and the attack vector and the complexity and also then the way that this can impact. And this is really around confidentiality. I think this is the ability for people to steal information which you otherwise would not want it to, which is the main impact of this vulnerability.
With Path Traversal, yep. So what else am I seeing here? Credit is basically this is the security researcher who reported or found it, which in our case, this is your team, right?
Yeah, so this is the Snyk security team. This is specifically this is Sam Sanu is a very talented guy who found this. We tend to give credit to the entire team in general, but it's nice to shout out live as well. We also have the CVE here, which is the common vulnerability enumeration, which is really the official ID that this gets inside like the not Snyk's database, but like the world database of enumerating vulnerabilities, or really, ideally, it would have all of the vulnerabilities in there. Snyk is a CNA, so a central naming authority of Meta. So we do, for the vulnerabilities that we find and we disclose, we assign CVEs to them as well, so that information is all public and available to everyone in the open source community. There's also the CWE here, just to confuse you, CVE and CWE. The CWE is the common weakness enumeration, which is basically, it's an attempt to basically provide a framework to enumerate and classify each and every vulnerability type. So CWE 22 is associated with the Path Traversal vulnerability type. So Path Traversal vulnerabilities will get CWE 22 most of the time. Yeah.
Cool. So you mentioned Snyk Code, and now this is where we're going to try and work with this project. And the cool thing is we're going to try and hack it in, right? We're going to see how we can, see the vulnerability and maybe reproduce it, maybe even fix it. We'll see, why exactly this vulnerability exists. But maybe a word, do you want to say what Snyk Code is, and I've kind of give you that banner to kind of lean into it?
Sure. The banners are very helpful. So when I forget what things stand for, I can always read it from the screen because I don't have a great memory, but I can read. So yeah. So Snyk Code is a SAST, or Static Application Security Testing product, which beyond that little blurb, what it actually means is that this is the tool that we give developers to be able to identify vulnerabilities in their own first-party code, i.e. the code that they're writing. So we're looking for vulnerable patterns, i.e. code that we can identify as having vulnerabilities in it, and letting developers know about this. And we're doing this, we're trying to integrate as early on in the dev cycle as always. This is dev first, as everything in Snyk. So as early on in the cycle as possible in every dev tool or every SCM, in order to give them this ability to sort of see that this is happening and find these vulnerabilities and fix them fairly easily along in the process. And yeah, and I see you've jumped over to the VS Code plugin here, which is really running Snyk Code in VS Code to kind of identify the vulnerability that we were just talking about. Want me to say what we're seeing?
Security issues, this is, just to be clear, this is not in open source packages or container images. This is in my own code, like a developer's own code when they write it on their ID, right? This is what we're talking about here.
Yeah, exactly. This is really just a helping hand to people to be able to help write safe and secure code. And we're trying to give the expertise that we have and that we've gathered over the various years inside this space, trying to distill that into something which we can give out to developers and have people like anyone writing code can kind of help use this and be a little bit more secure.
Got it. Okay, cool. So what am I looking at here? I understand now this is about secure coding, static application security testing is my own code. Do you want to give me an idea of what this is? And just to give the context, we have checked out the vulnerable version of that browserless Scrum project, which, as we said before, just get people onto that context. Your team found this Path Traversal in browserless Scrum, which is an open source project on GitHub, as well as this service thing that flies and hosts on the internet. So we've cloned this, the code here from GitHub and moved into the specific vulnerable version for it. Since we said, as you've said before, this is something like 9 months old vulnerability. So it has been fixed since then. But, now everyone has the context and we're looking at a code. You could take us through what we're actually looking here.
Yeah, so this is basically the bit of the code which is accepting user input to allow them to access files which they've uploaded to their system. So each person inside, so just the context is, people, like as you said, like browserless Chrome can be used to take pictures or to access various stuff on various websites. And there's information that you want to save in your local file storage inside this hosted website. And this is basically the input which is allowing you to have a look and access that kind of information which is inside your own file. So it's asking for that user input to kind of look at this. Now, the issue becomes here, and what we're flagging out here on the side from the unsanitized input, is that specifically in the params which is really from the user input, it's not doing any kind of sanitization, which is allowing it to be open to this path traversal, because it's basically allowing you to put any kind of input into there, which will allow you to traverse. Now, what a path traversal genuinely looks like, we might want to jump to the screen before that to show the POC. But what it generally looks like is, well, a lot of little dots. Because what you're doing basically is you're telling them to go back. The double dot obviously means go back along the file path name. And if you don't sanitize or control for that in any kind of way, an innocent request for a file inside your own file system can allow you to really traverse that all the way back and do this. And what Snyk Code is kind of flagging out here is it's identified that there's a request for this user input for a file name, and no sanitization of any kind is kind of being put in, which is why it's letting you know that there is likely a path traversal vulnerability to be identified here. And it's showing you exactly where that line is, and also explaining to you what it is that this vulnerability kind of entails. And I don't know if it shows it to you specifically in the IDE or whether you have to jump to the page itself, but it will also give you some greater context on what path traverse vulnerabilities are and different ways that you might fix this inside your code as well.
Right. So if I understood you correctly, and I'm looking at, this is basically on the Snyk extension here on my VS Code, which works with JavaScript and TypeScript projects. It kind of it linters what this kind of vulnerable code. So it helps me figure out what's going on here. And you're saying this is an input coming from the request object flowing somewhere inside to at the end of it, like if I'm also reading, what the extension is telling me here on the screen, it's like it's unsanitized input is flowing from the HTTP parameter, flows into this area, which I can click on, and then it will navigate into specific places, and could be resulting in path traversal on line 175, which again, if I click on, just need to click on it, and it's here highlighting this issue, right? This is basically the way that you've just talked about before, the attack vector on the CVSS. Talking about confidentiality. So confidentiality loss is high because I'm basically now able to maybe traverse the file system and access files which I shouldn't, like Sam was showing us here with his demo. By the way, this is Sam putting this POC available, right? And working with a maintainer with this example to show them how this is actually exploitable as well, right? This is part of it.
Yep. So this was Sam working hand in hand with the maintainer to demonstrate the vulnerability to them. So set up a whole POC to show them what it is, and then help them look at the fix and work on it. Maybe we want to talk about the fix as well and kind of how the maintainers sort of look to fix this. And I mean, because we've talked about sanitization quite a bit, and we said there are various ways that you can sanitize and everything, and we want to be looking at it. And there are generic ways that you can look to sanitize data, and you can look to simply remove double dots, for instance, as part of the sanitization, or look for special characters and remove them. That's kind of the generic ways that I think most people would approach to look at sanitization, and that might be a lot of the time what we look. Various SAST tools might look and identify that as a sanitizer. But what's specifically interesting here is that the maintainer took a little different approach to how they wanted to look to sanitize this. And it was thanks to the fact that we had a little back and forth with them, and also thanks to the way that we kind of look at vulnerability and the security experience that we have, they were able to sort of identify a different type of sanitization as well, rather than generic. Do you want to jump to the commit?
Yeah, I'll do that. Let's see if we should be somewhere here, right?
Yeah. So again, we always in our advisories, we try and put like references, which are the most helpful for people to find them. So here we're really showing them, we have the vulnerable code and also the commit as well, which is what fixed this. So what's interesting here is that the solution that we're seeing here, which is this fix, which fixed it on October 26th, doesn't seem to be sanitizing at all, right? I mean, like, and if you look at the commit name, it doesn't say sanitize anything. It says ensure file name dir, which is kind of workspace files are in the workspace dir. Cool. So there's a little bit something which is a bit odd happening here, which might confuse people who are just looking at this or like a classic static analysis tool, which is looking for just classic sanitizers in order to identify it. But what's actually happening here is what they're doing is they're trying to check and see, does the input include the workspace directory, i.e. it first of all takes the input that's coming in from the user, it resolves it to see what it is that it's looking for, and then it checks to see, does the workspace directory exist in that file path? What does this mean? It means if someone were to add if somebody were to introduce a path traversal, which would say the final path wouldn't be inside my workspace because I would have traversed out of that, i.e. to the root or elsewhere, this will, as it says, it will return a 404. And this is basically a way of blocking this. So rather than trying to sanitize the special characters or anything, the specific logic in the context of this library said, I'm fine with them traversing wherever they want to go inside their own workspace directory. That's all okay. All I need to do is to check if at the final thing that they're trying to get to, the final path which it's resolved to, is it in the workspace directory? If it is, that means it's safe. If it isn't, it's not. That's really a context-specific type of vulnerability, but type of fix for this vulnerability. But we do see these things kind of crop up quite a lot. And it's part of our job when we're building a SAST tool to be robust enough to not just identify if someone specifically sanitized it using the very easy to notice sanitize path traversal function, but also things which are a little bit more context specific as well. And that's kind of the thing that we're trying to do here. Not to say that we get it 100% right all the time. I keep on saying this code is complicated, bugs exist, all of these kind of things. But we really find that the knowledge that we have and the specific context that we're able to gain is really helpful for us to be able to identify more of these and give these and reduce the kind of false positive and noise which otherwise we might introduce into the system.
Love it. Love this the whole intro, as well as what could actually maybe confuse maybe other SAST tools, and the way that we actually also, I'd say, proof shielding it in terms of the true positives that we actually find, right? This is not on a benchmark project, like you said. This is actually we're letting the tool run on actual vulnerabilities that we find that we know are legitimate, and then kind of like fine tuning it to make it as precise and as low false positives as possible, so to say.
Yeah. And I mean, it's just about finding the stuff in the real world, that real world knowledge which the team was able to gain with years of experience in this kind of space, and introduce it here as well.
Yep. So let's live hack it and show the way that this actually works and create. And I have this whole environment here, so I'll be going back and forth between different screens. I do want Benji, just take maybe a minute or two to explain to developers who are trying to understand how this comes to life and why is this a vulnerability. So let's see what we have in the code itself. If we go over here, we're seeing again request parameters going in, and there's a path join workspace directory and file. So it's actually joining two directories or two file paths, if so to say, and then continuing on, right? So if I were to try and explain what it is, and I'll go here to the node, the interactive node, the REPL CLI here, explaining what's going on. So imagine basically there's path join. This is a function in Node.js core that allows you to join two different paths. So this is maybe user src workspace, for example. And this is maybe you wanting to access a file inside that workspace. So maybe Benji is something, I don't know, maybe that exists. You could see that the response of that, if I hit enter here, you could see that this is actually just joining the paths. And so what the vulnerability comes to life is, not when I'm trying to, put absolute paths, but rather the fact that I'm actually trying to now traverse this tree of the file system and go out. So, if I did something like that, which is, common, proof of concept to try and access files, this is why at the end of that, path join giving you the file path variable might end up leaking outside of the, what is supposed to be kind of like a jailrooted, like a contained environment. So this path join now will result in this /etc password. And there's no other sanitizations like Benji was talking about here that conflicts you to that workspace. There's none. It just checks if the file exists. If it does, it will go ahead and, stream it back to you, which is really, this is, if we talk in SAST terms, this is basically the source to sink kind of things, right, Benji?
Yeah. And I think that this is, again, like what you've resolved back there, that etc password, you'll be able to see as a thing which, whether or not, like, this is kind of where this fix is going to come in, because the join at the end of the day will resolve in this etc password rather than anything which is going to have the workspace directory that is a specific context you're supposed to be working in.
Okay, awesome. So what I'm going to do now is I'm basically going to take Sam's POC here. It is saying, run Docker thing here. So I'll do that. I have this Docker environment here. And let me see, it should this autocomplete this for me a bit. Right, I needed to check not to check, but to pull a specific Docker image version tag 139, which was the vulnerable version, because after this, a lot of versions were fixed, but also they received probably retrospective fixes to backported versions. So I'm going to run this and, let's see what happens. Hopefully it doesn't pull anything right now because I've already pulled that before. And maybe it's running. Let's see. Probably checking if the image exists. I'll pull here localhost. Go. Okay, so this is running. This is the browserless project, right?
Yep.
This is it. It's running there. And yeah, so it took it a second, and now it got all of this, like all of this output. And I'm going to go ahead and use this curl command. I'm just going to clean it up a bit from what Sam was doing there. What it actually is doing, now let's see in the CLI. I'm supposed to get that password etcd, right? So open this here. So again, this is the container running. Just pulled it from Docker Hub. If you were running this version, please upgrade. This is a small advice here between the lines. What's going on here, Benji, before I kick this off?
Yeah, so what we're seeing here is what actually the kind of thing that you're trying to request here is you're trying to really get well out of your workspace and all the way to etc password. So you're traversing back and back and back and back until you essentially get to the root. You don't really know how many times back you need to go, but it's fine because basically once you've got to the end of the file path, like it doesn't matter if you try and go one stage back. That will resolve back into the last possible file. And then you're basically going check and see if we can get to etc password. Now, just important to note, like Liran doesn't know for sure that this file path will exist on the file server, but it's a good bet that it will exist on like some kind of Unix server, as it's like a very common sort of file to sort of do that. So this is what's happening. We're guessing ahead of time what are the commonly sensitive files that we can reach way back on the file path.
And like you said, I think at the beginning, talking about like weaponizing and Metasploit kind of like exploits on this, they're basically automated tools that, just do all of that, right? They send like thousands or, hundreds of thousands of requests, different kinds. They try XSS and Path Traversal, then access some stuff on your website, some domains, some IPs. And, if they find something, that is the low hanging fruit that they're going to try and get into and kind of like, weave their way inside internally. And, who knows what happens from that point on.
Yeah. No, which is again, the more POC, the more likely there is of POC out there, the more likely that there is that you're gonna face some kind of breach. It's just simplicity.
Yep, got it. So should I the cliffhanger here? Should I click?
Let's see. Let's steal this passwords.
Press the button. There we go. I just did, and I'll scroll this a bit up so you could see the whole thing. We've just accessed etc password, which doesn't have any real significant meaning, but it shows us that I can access this. So I could actually I could put myself, Benji, right now in the heads of the brain of a hacker, and what they would actually do is, hey, they've got in, so etc password is maybe not that interesting. Maybe SSH is not open, etc. If they were able to find anything here anyway, they could go and say, hey, maybe this is a Node.js project, and they'll go and try and access the package.json, and from there maybe the log file, maybe the node modules, and they'll figure out they now have access to read any file that you have on the file system on the running container here. So they would go and say, hey, I now know all of your node modules dependency tree. Let's find one that has a vulnerability in it. Or maybe you're just not practicing kind of like secure coding conventions, which is maybe you have like a config.js or I don't know, something else kind of like file that has API in it, and they'll steal that API key to AWS, GCP, whatever that is, and that's also kind of putting you at risk. So Path Traversal seems innocent, but right, Benji, it could have severe implications here.
It can have a lot of severe implications. Another implication that I want to discuss here is that this is a file, this essentially means this is a hosted service which has multiple users. So by allowing you to access the core root, it's not just, you'll also be able to see all of the different other user files that exist on the system and look at all of their information as well. So it's not just about the risk that you're putting yourself at. If you're hosting a service and you're giving it to additional users or anything like that, a lot of the time the people who can be affected by this are the innocent users which are using your project, who are hoping that they're going to have information there which is secure, and this allows that kind of stuff to be accessed as well. So there's a lot of different ways that this vector can kind of put all of the information that's kind of stored here at risk.
Yep. So should we fix it?
I don't know. Let's not leave people in suspense.
Okay. So to show how I fix it, and actually I wanted to open this parallel to this. Might be a bit easier to see stuff. What we should be doing is pulling in your version of that image tag. There we go. Or should I stop it? There we go. I think I have 42, which I checked out before. Is that one going to run? Let's see. I guess here we need the same kind of...
So this is the fixed version, right?
Yeah, this should be the fixed version. So let me see. So this is running. I'll go in and just see that we still have it running and everything is okay. So yeah, you won't notice any changes here. This is just the app, the browserless Chrome project running. And this is the fixed version. So doing the exact same thing here now results in not found, right? And this is because basically, if I also switch to the latest code version, which you see I'm on a branch that has the vulnerability in that specific Git tag, switch back to master, which is where they push it. You could see also that the Snyk Code extension on my VS Code is actually running this live, and maybe there are other issues here that I should worry about. But you see that this is it's running live and pretty fast, right? Like 14 seconds, and all the project here found 28 issues, which we won't go into now, and probably hopefully someone is looking at them from that maintainer team. But this is the fix that you were discussing before.
Yeah, that's the fix that we're discussing there, and that's what should be basically preventing the identification of this vulnerability. Yeah, and I mean, as again, we can see that what it shows us is that it's doing the check for it's doing the check for the workspace directory, and that's exactly why we got that 404, that the file not found, because when we try to do the Nordic payload, it realized that it would not be inside the workspace directory that we were supposed to be in.
Got it. So any more?
Oh no.
How was the process of disclosing this? This was basically Sam and the security research team working with the maintainers on a fix, I guess, right?
Yeah, and it was very, and I mean, we worked with the maintainers here. They were very susceptible to coming and helping out. They came up with the solutions, everything like that. They were very rapid in their response time, and it was a pleasure working with them. If all disclosures could be this nice, it would be lovely. But again, as you know, this is a paid team working on a paid project, so it's a little bit more easy for them to find the time in order to invest in this and to do this in a quick fashion. Obviously, it becomes more complicated when people are doing this out of, for the community and the goodness of their heart, and they often need more time and more support from us, from Snyk, from everyone inside the community to help and get this done.
Got it. Thank you so much for this whole report disclosure process and letting us kind of like get the deep dive into it, Benji, because this I think has been both very high level, like talking about SAST and security coding practices, and your intro about I'd say security research as well. Deep in the roots here, right? Practical advices on how we actually find secure coding issues like path traversals that happen in real life projects. And that Docker Hub image, I looked at it before, it has 50 million pulls. That's a lot for a project that's very popular, and that's great that they're putting also the effort to kind of like work with you on a timely manner to basically fix and mitigate all of those security vulnerabilities. So it has been great seeing it. Maybe wrapping it up with this is Snyk Code that we've been using on my VS Code setup. You've seen this small tab here for the nice little patch dog. You can just find it. I'll add it here as well. Over here on the banner, but basically, if you just go to extensions and you just search it in the marketplace on VS Code or on IntelliJ, which is available for both. What is it? The Snyk, right? It's I'll just find Snyk, and this is it. Snyk vulnerability is kind of this is where it's at. This is my installation for it. You could start using it as well. Find issues while you code and get all of this advice of how to fix things as well. That's like the interesting part where we kind of like use kind of like the crowdsourcing intelligence. So what are the fixes that we kind of like recommend on? And I mean, Benji, this has been great. Did you want to add anything to that VS Code, the Snyk Code intro?
I just think to say that we put a lot of work into trying to make sure that we're using all of the security expertise that we have and all of the understanding that we have of the languages and the different frameworks at work to identify the best rules to use for it and the best kind of sanitizers and other things in order to give users the best experience. We're really happy to get more feedback on that. Our support team is very helpful in collecting that support from users and from customers and getting that back to us and allowing us to iterate and improve. So help us to help you.
Love it. Cool.
All right.
So,
Thank you very much, Liran.
Wait, before you go, one thing I will throw your way here is if anyone wanted to get started with security research or security coding, and this kind of if they wanted to get a job at Snyk basically on this role on your team, you are recruiting, right?
Yeah, I mean, we're always in the process of recruiting people. Yeah, then you should check out the job openings at Snyk. We're always looking to bring in more people, more for all of the different populations inside the security.
What are you looking for? What are you looking for when looking at candidates? Where should they go to get started or get experience that you're looking for?
So I think that one of the problems in security is that it can be somewhat gated in terms of the type of research, the type of background and stuff like that. I mean, we talked about my background at the beginning. I was very lucky to have that kind of thing, and not everyone is going to have access to that. And I don't think academia is yet at the point where we're cranking out good cybersecurity researchers in a lot of different places. We're not quite there, I think. The academia hasn't quite caught up with the population at large and what's happening. But there's a lot of places where people can contribute. And this, we mentioned bug bounty programs and stuff like that. HackerOne has a great bug bounty program. We have our own vulnerability disclosure program. We literally just hired somebody, a great guy, Alessio, who he sent us disclosures for quite a few times. And we just reached out to him and was like, Matt, would you like a job? You're doing such a great job at this. Would you like to come and just do this for us? And we were really happy to bring him in and onboard him. But I mean, not just our own end, but looking at these kind of places, these sort of programs which exist, a lot of CDFs and stuff as well, which a lot of people, including Snyk, but others as well, Google have a really great one. It's still
what is CVX?
CTF, sorry, capture the flag.
Okay.
Yeah, capture the flag. So this game, gaming, gamifying the approach to to finding security breaches and stuff like that. It's a really good place to sort of get to cut your teeth into. And a lot of people are very interested in looking at people who have a proven record even if they're like doing stuff in their spare time or like of doing this, of founding these vulnerabilities or have this kind of understanding. So I think if people don't necessarily have that background but are looking to get more involved, that's certainly something which they can do in their own kind of like time. But also like a lot of people who are dealing with code anyway and who are like engineers and stuff, they've probably got a lot of great security context as well and stuff that's like really interesting. They're probably dealing with these issues on a day-to-day. The modern developer deals with security all the time. There's no big differentiation between security and developers anymore. So I think a lot of people are sort of coming in from that kind of place as well, and that's really great for us to see.
It's a lot of insight that you're looking at for recruiting, and I like all of these examples, the CDFs, the bug bounties, and that's like a really great story of someone basically being active there, and your team kind of like reaching out, offering kind of like, send us, maybe kind of like a ping, and like if you're interested, we'll happy to kind of like start the interviewing process, and that's amazing. Yeah. It's a really great success story.
We like to think so, yeah.
Awesome. So if you wanted to, get involved, with security research on Benji's team, we have the link right there. You could like, send in a CV or a ping. You could also tell Benji that you're also into philosophy and cooking, and maybe, get on his good side, right?
Yep. I mean, that's the best way to become a security researcher. Cook a lot and study philosophy.
Cook Path Traversal exploits and send them over.
Yeah.
Well, Benji, it's been a pleasure. Thank you so much for all of this insight, your background, of security expertise. You're deep diving into it. What else? Any final words before we leave you off to your afternoon, your evening?
No, I just wanted to say thank you very much, Liran, for having us and allowing us to talk about the Snyk Code and the work that we do in the team, and wish you all the best of luck in Snyk Live going forward. I know it's going to be hard to top this session, obviously, but good luck with that.
Well, I'll do my best. Thank you.
All right. Thanks very much. Thanks, everyone.
Thank you. Bye-bye. Thank you, Benji. And we'll see you all on the next stream. I'll leave some comments afterwards on how you could find all of this information. And we have a website landing page. But basically, if you're tracking and subscribed to the Snyk YouTube channel, as well as on Twitch, we'll be happy to see you in 2 weeks from now, every Tuesdays. We'll also be happy to ask you, what topics you're interested for us to discuss on. More secure coding, more tech stacks, whatever you want interested of hearing about, ping us. So thank you all for joining, and have a great rest of the day. See ya.